recording.
This afternoon we're doing more on rates of reaction. This is your student experiment, so it's very important that you know quite a bit about how rate is measured. So some of the theory to explain why parameters affect rate, and those parameters are, what are they? What are the things that affect rates of reaction?
Temperature.
Temperature, thank you. One.
Concentration.
Concentration. And one more. Said.
Surface area.
Surface area
Volume.
to volume ratio. Yes, very important. Those things. Why do they affect the rate? It's got to do with collision theory. So collision theory, that's what I'm going to write up here. Collision theory you have done since year 8 science. It is essentially the states of matter. So solids are said to be made up of atoms that are only slightly vibrating. Nothing in existence would be still, otherwise it doesn't exist. There's no energy, it doesn't exist. So the particles in a solid are slightly vibrating. When you change the state of that by adding temperature, for example, and it goes to a liquid, the particles now have more energy, more kinetic energy, and they're moving over each other, flowing. So that's liquid. Gas, they've got a lot of energy. They're a long way away from each other, and they're travelling in straight lines at very fast speeds. So that's what's in your head when you're thinking about collision theory. So this is the collision theory that I want you to write down. Here it is. First point. Individual particles of the existing substance must collide in order for a reaction to occur. So, unless you can get those particles to collide with each other with enough force, they're not going to react. And that's why all those parameters make the rate of reaction go faster. You think about it, if you have more concentration, it means you have more particles. If you have more particles, the chances of them colliding is greater. Do you agree with that? So you need to say this in some of your answers. If you heat up, if you add temperature, if you heat up the temperature of a system, they're moving faster, which gives them more chance of collision. The probability of them colliding, if they're moving faster, is higher. If you add a catalyst, such that this catalyst, remember I was telling you how catalysts have the ability to attract particles to them, you're reducing the area, more likely for collisions to occur. If you have a larger surface area to volume ratio, so if your surface area to the reacting liquid is large, more chance of collision between the two different reactants over a large surface area. So it makes sense, doesn't it? So you've got to use collision theory. So that's the first point. The second point, the collision energy must be equal or greater than a certain minimum amount of energy known as activation energy. EA is the symbol. So a good example of this is want wood to burn. Wood will combust in oxygen, but first you've got to put in a huge amount of energy to get it going, and then it keeps going. So activation energy has to be reached before all those molecules are going to react. Another good example is burning magnesium. Combustion reactions are really good examples of this. You have to get it up to a high temperature before it'll start to combust. So 2 factors so far. They have to be collide, and they have to collide with enough energy. They can actually just bounce off each other. So just because a collision has happened doesn't mean they're going to react. It means that they could just bounce off and stay as reactants. They have to collide with a lot of force in order for a reaction to occur. And the last point, the reacting particles must collide with a suitable orientation. Orientation in space. So this is another way you can explain how catalysts work. Catalysts do not get involved in the reaction. They're never used up, but sometimes just their presence means that the molecules get into the right orientation for a reaction to occur if a collision occurs. So they're the 3 things. Now, sometimes these sorts of facts mean the difference between a C answer and an A answer. If you're asked to justify why concentration has increased the rate and you use collision theory as part of your answer, you're going to get better marks. Alright, so the question I want to do with you now, and this is the final bit of the recording, is the one with the balloon on the top. Which one's that? Question 5. Everyone have a look at that. So question 5, I'm going to just flip this board quickly and draw it on the other side of this. Alright, so question 5 looks like this. Conical flask, and in here you have some marble chips like you'll have this afternoon, marble chips, calcium carbonate, and you also have some hydrochloric acid. So a reaction is occurring, and you know, because we've already talked about it, what is being formed. What is one of the products?
Carbon dioxide.
Yes. So carbon dioxide is inflating this balloon, CO2. It's gone from, you can imagine it, but I'll try to draw it. Here's your balloon initially, and it's just sort of slumped over the side because it's empty. Isn't it? Like that. And then as the reaction proceeds, you're getting more and more carbon dioxide, and you're not losing it. Because if this is on a balance, you're not losing anything from the reaction. Alright, let's read this question together. Calcium carbonate pieces are placed in a flask and hydrochloric acid is added. Immediately a balloon is placed over the top of the flask. The balloon then starts to inflate. So the first question is quite easy, isn't it? Explain why the balloon inflates. You need to be detailed. So you would, as a chemistry student, you would write the balanced chemical equation showing all products, but particularly the carbon dioxide, and say carbon dioxide is one of the products that's coming off the reaction and inflating the balloon. And then the second part, in a second experiment, the same mass of calcium carbonate in a powdered form is used. So this time, instead of having these sort of solid pieces, you're just going to have powder. So in the second experiment, I have this sort of calcium carbonated powder and your hydrochloric acid and your balloon. And what does it say? Explain why the balloon inflates faster when powdered calcium carbonate is used. Faster. So it's, you know, really going in fast. What would you say?
A larger surface area to volume ratio,
Yes.
and then it's like more collisions happen.
Very good. Use collision theory. Very, very good. So the reason is, yes, you've got a greater surface area to volume ratio in these little particles that are powdered. So you're getting more exposure of the atoms to the liquid. And this is due to increased collisions between reacting particles. What else are they after? Yeah, that's it. Using the same chemical substances, calcium carbonate and hydrochloric acid, discuss a different way to make the balloon inflate faster. In your answer, you should refer to the rates of reaction and particle collisions. So, what do you think? What's another way we can get this reaction to happen faster?
Could you heat it up? Or, I don't know.
Yes. We could heat it up. We could definitely do that. So you could get your conical flask and you have your... actually, you can get it to go faster than this. This is going a certain pace. This is going faster because it's a finely divided powder. And then if you use powder again, but your hydrochloric acid now is at 20 or 30 degrees instead of 21 or whatever it was, it's going to go faster, isn't it? And you could then use, higher temperature, and then you use the collision theory. Higher temperature results in higher rate of reaction due to, what are you going to say?
The particles collide more frequently.
Yes. Due to increased rate of collisions in the reacting particles, resulting in product formation. Not just increased rate of collision, but increased rate of collision with enough energy, because you're adding energy when you add temperature. So due to increased rate of collisions and at the required minimum energy level, because it'll be that and more. Can you read that? At the required minimum energy level in the reacting particles results in increased product, leaving words out everywhere, increased product formation. Does that make sense? Something like that?
Yeah.
I'll read it to you because it's so terrible. Higher temperature results in higher rate of reaction due to increased rate of collision at the required minimum energy level in the reacting particles, resulting in increased product formation. You probably could word it much better than that. So that shows you about collision theory. So there is no reason, there is a lot of questions here with pictures and graphs that I'd like you to do now before you do the experiment tonight, or anytime you can. It'll give you a lot of ideas of how to present your own data for the experiment.